Grounding an antenna to a copper water pipe is generally acceptable, provided certain conditions are met and relevant electrical codes are followed. The primary purpose of grounding an antenna is to provide a path for electrical surges, such as those caused by lightning strikes or static discharge, to safely dissipate into the earth, protecting both the antenna and any connected equipment. Connecting the antenna ground to a metallic water pipe can offer a low impedance path to ground, which is crucial for effective surge protection. However, it's imperative to ensure that the water pipe itself is adequately grounded. This typically involves verifying that the water pipe is electrically continuous and connected to a grounding electrode system that meets the requirements of the applicable electrical code, such as the National Electrical Code, or NEC. The NEC provides specific guidelines for grounding and bonding electrical systems, including those related to antennas. Section 810.21 addresses the grounding of antennas and leading conductors. It stipulates that the grounding conductor must be connected to a grounding electrode system as covered in Article 250 of the NEC. Article 250 details the requirements for grounding and bonding, including the types of grounding electrodes that are permitted and the methods for connecting to them. Acceptable grounding electrodes include metal water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. When using a metal water pipe as a grounding electrode, it's essential to ensure that the pipe is electrically continuous and in direct contact with the earth for at least 10 feet. If the water pipe is interrupted by insulating couplings or has non-metallic sections, it may not be suitable as the sole grounding electrode. In such cases, it must be supplemented by another approved grounding electrode. It is also important to bond around any water meters or other potential discontinuities in the water pipe system to maintain electrical continuity. Bonding involves connecting a conductor across the discontinuity to provide a low impedance path for fault current. The size of the grounding conductor used to connect the antenna to the water pipe must also comply with the NEC. The size is typically determined by the size of the antenna leading conductor. For example, the NEC specifies minimum sizes for grounding conductors based on the size of the service entrance conductors or the antenna leading conductors. Proper installation techniques are crucial for ensuring an effective and safe ground. The grounding conductor should be as short and straight as possible to minimize impedance. Sharp bends and long runs can increase impedance, reducing the effectiveness of the ground. The grounding conductor should be securely fastened to both the antenna and the water pipe using approved grounding clamps or connectors. These connectors should be made of a material that is compatible with both the antenna and the water pipe to prevent corrosion. Corrosion can increase the resistance of the connection, compromising the effectiveness of the ground. In addition to grounding the antenna itself, it's also important to ground any associated equipment, such as amplifiers or splitters. This equipment should be grounded to the same grounding electrode system as the antenna to ensure equipotential bonding. Equipotential bonding helps to minimize voltage differences between different pieces of equipment, reducing the risk of electrical shock and equipment damage. Furthermore, it's recommended to install surge protective devices, or SPDs, at the point where the antenna leading conductor enters the building. SPD can help to protect sensitive electronic equipment from voltage surges that may not be completely mitigated by the grounding system alone. SPD work by diverting excess voltage to ground, preventing it from reaching the equipment. When installing an antenna grounding system, it's always best to consult with a qualified electrician or electrical engineer to ensure that the installation complies with all applicable codes and regulations. A qualified professional can assess the specific conditions of the installation and recommend the most appropriate grounding methods and equipment. They can also perform tests to verify the effectiveness of the grounding system. It is also important to note that local codes and regulations may have additional requirements for antenna grounding that are not covered by the NEC. These local requirements may vary depending on the jurisdiction. Therefore, it's essential to check with the local authorities to ensure compliance with all applicable codes and regulations. Some common grounding practices include using a ground rod as a supplementary grounding electrode. A ground rod is a metal rod that is driven into the earth to provide a direct connection to ground. Ground rods are typically made of copper or copper-clad steel and are at least 8 feet long. When using a ground rod, it should be installed as close as possible to the antenna and connected to the grounding conductor. Another common practice is to bond the grounding electrode system to the building's main grounding electrode system. This helps to ensure that all metal parts of the building are at the same potential, reducing the risk of electrical shock. Bonding can be achieved by connecting a conductor between the grounding electrode system and the building's main grounding electrode system. In summary, grounding an antenna to a copper water pipe is generally acceptable, provided that the water pipe is adequately grounded and that all applicable codes and regulations are followed. It's crucial to ensure that the water pipe is electrically continuous, that the grounding conductor is properly sized and installed, and that any associated equipment is also grounded. Consulting with a qualified electrician or electrical engineer is always recommended to ensure safe and effective installation. It's also important to consider other grounding methods, such as ground rods, and to bond the grounding electrode system to the building's main grounding electrode system. By following these guidelines, you can help to protect your antenna and connected equipment from electrical surges and ensure the safety of your home or building. Remember to prioritize safety and always disconnect power before working on any electrical equipment. If you are not comfortable working with electricity, it's best to leave the work to a qualified professional. The grounding system should be inspected periodically to ensure that it is in good condition and that all connections are secure. Corrosion and loose connections can compromise the effectiveness of the grounding system. If any problems are detected, they should be corrected immediately. Grounding is a critical safety measure that helps to protect people and property from electrical hazards. By understanding the principles of grounding and following the applicable codes and regulations, you can help to ensure a safe and reliable electrical system. The importance of proper grounding cannot be overstated. It is a fundamental aspect of electrical safety that is essential for protecting people and equipment from the dangers of electricity. By following the guidelines outlined above, you can help to ensure that your antenna grounding system is safe, effective, and compliant with all applicable codes and regulations.